Hi everyone, this is Pavel with a Visual Basic exercise. This one is from the book Introduction to Programming Using Visual Basic, chapter 11, and this is programming project number 2. And the programming project number 2 simply wants us to create a game of blackjack, or kind of like a simulation of it. Now, this is a take 2 for these videos. I already made them, but they're just really horrible, the sound, and the video was all messed up, so I'm redoing it, but that means that I already have the actual program running already. So I'll show you what we are building. We got a little form for the player, this list box for the player, list box for the computer or a dealer. When the program starts, we have a new hand. I'll click that. 2 cards are given to the player and 1 to the dealer, and then player decides whether he wants to go or hold. So I'll click hit me, and when it comes to aces, it's a good thing that it just popped up. I hope that you know how to play, blackjack to 21. But ace has a special meaning. It could be either value of 1 or value of 11. Now in this case, since we are already having 8 plus 3 is 11, if ace was 11, we would be over 21. So the program automatically kind of knows that we need to make it 1, otherwise we would be already over. If I click hit me again, player percent is over 21, dealer wins, because obviously the player got busted. So when I click new hand again, another 2 cards for the player, 1 for the dealer. We have 16. I'm gonna hold, and the dealer goes, and the dealer tries to go as high as the player, at least. Obviously, because dealer would win if let's say if dealer now got 16, the dealer would win, because dealer wins if it's kind of like a draw. But the program also knows, like, if a dealer had 3 cards and the score would be the same, but the dealer would have only 2, a player would have only 2 cards, then the player would win, because he would have less cards. So but this is basically what it is, a simple poker game. Again, we had an ace that it could be 13, so but in this case, it could be 13 at the beginning. 2 plus 11 would be 13, but if I add 10, which is queen, it would be 23. So it automatically knows after I draw queen that ace now has to be only 1 in order to fit within 21. So, and coincidentally, it's still 13, because 2 plus 1 is 3 plus 10 is 13. And here I am again over, so the dealer wins. Now I have king of diamonds, king of hearts. I have 20, so I'm gonna hold. And now this is a good example. Dealer has 20, but player has 20 and 2 cards. Dealer has 20 and 3 cards, so player wins. So, all right. So this is basically the form. This is the rules are quite common. I hope you know them. So we can start coding. Like I said, I already have the code actually available, so I may copy paste few comments, but I will do everything on screen, or as much as I can. So the form itself is very simple. 2 list boxes, 2 text boxes for the score, 1 for the player, 1 for the dealer. These are read only. I have 1 made like a message text box. Read only, it will say the messages and who won. And then there's 3 buttons. Hit me, new hand. New hand is the main button when we start the game. Hit me is when the player wants more cards, or hold when the player wants to stop. Once hold is pressed, then the dealer draws his cards, or the computer draws his cards, and like I said, tries to match the player's hand or get better. If player goes over, like by clicking hit me, the dealer automatically wins. Dealer only draws the minimum amount of cards in order to win. In other words, 1 or 2 cards. But you'll see the logic later as I code it. Okay, so the first thing, this is from the chapter about object-oriented programming. So they want us to actually use some classes, and it makes sense in this case. Why not? So let's do create a new class, and I'll call this class card. And there are different ways on doing this. The way I'm going to do it, here's my comment. Basically, it's a standard deck, 4 suits, 13 cards of each suit, 2 through 10, and then Jack, Queen, King, and Ace. Again, in Blackjack, Ace can have value of 1 or 11. So alright, what is it missing? Oh, never mind, like that. Okay, so that's my card, and I'm going to do an enumeration of suit, and it's gonna be hearts, diamonds, clubs, and spades. And I could do enumeration for the for the values of the card, like 2, 3, 4, and whatever, 10 for the Jack, Queen, and King, and 1 and 11 for the aces. But I'm gonna do a structure instead. In this case, I'm just gonna call it cards, because this is gonna be like the not just one card, but like structure of all cards in the hand or in the deck. And it's gonna be card value. It's gonna be card value string, and I'll explain why I am doing this as a string as well. And dim card suit as, and this is gonna be the suit enumeration. Now the integer value of the card is simple. It's 2, 3, 4, 5, 6, 7, 8, 9, and 10. Again, 10 is also for not just for the number 10 card, but also for the Jack, Queen, and King. So they will all have value 10. And however, I want card value of string because I don't want to output something like 10 of diamonds when it in fact is let's say Jack. I want to output Jack. And the player knows that the value itself is 10. So the card value string will simply hold the values for the Jack, Queen, King, and Ace. They all have their own numeric value for the game, but for the display value, I want to display them as Jack, Queen, King, and Ace. So that's what this is for. That's why card value string and as a string. And that's really all for the card. And now we can actually do the deck. So it's got another class, and I'll call it deck of cards. Okay, and I'll paste the comment from my code that I already have, and so we know what we are doing. So this is gonna be the deck of 52 cards. It inherits from card, so let's do that. So we write inherits card, because we need obviously the card itself. We need the suit and the value in order to make up the deck. Now you know what, I don't think I'll need any of this anymore, so let me just close that. So after the class is instantiated, everything is created automatically via chain reaction of calling appropriate subs and functions. And you'll see that in the code. I will basically have one method that will call series of functions and subs and populate the deck. At the end, we get a stack of 52 cards that are being shuffled. Now I'm going to use a stack of 52 cards simply instead of an array. I will use both. At the beginning I will use array, which is gonna be the deck, and I'll shuffle it and then I'll place it into a stack. And the reason why I'm doing it this way is simply because I wanted to practice using stack. Really, we could use the array as is, as you will see later. So this is basically just for the practice reasons. And you know, you got a stack of cards. So and you take only the one on the top at a time. So it makes actually sense. But again, it's not really necessary in this case. All right, so let's do the deck. Obviously we need 52 cards, so that's 51 because we start from 0 as cards. And we need them and I'll call it shuffle deck as and again like I said before, it's gonna be a stack, and it's gonna be a stack of cards. So we will pass the array into our deck. So let's do our public sub, like our constructor, our new, and in it we will initialize the shuffle deck equals new stack of cards, and we're not gonna do the array in there. We'll do it in a sub later on. So again, I will just paste some comments in there in case you want to download the code later. You know, it's good to have some comments. And okay, so obviously it creates the deck of cards. It holds 52 cards that are populated and shuffled. And again, shuffle deck is a stack and holds a stack of cards that are transferred from deck, which is the array of cards. And like I said before, I just wanted to practice using stack, that's all. At the end, we call create deck a method, which I'll call in a minute, that will trigger the populating the deck. Remember, I told you that this is gonna be like a chain reaction, and one of the first thing that we will have is a method called create deck. But before that, I'm going to do a read-only property for our get shuffled deck that will return the stack of cards. Shuffled deck. And like I said, it will return the stack of cards. Alright, so this is a read only because we're not gonna set it manually. It's gonna be through the code. So all we have to do is retrieve the data, not really place any in it. So and it will simply return the shuffled deck, which is the stack. Okay, so now that we have that, the first method I'm gonna do is it's gonna be called create deck. It will simply create the 52 cards, you know, with the suits and the values in it. So it's gonna be private sub create deck. And this method, create deck, is the one that I'm gonna call from our constructor. So when the deck of cards is created, obviously the constructor is triggered, and it will automatically call the create deck method or a sub. Now, let me make some comments there. These are quite a few. Alright, so we are creating deck of cards, 13 face values and 4 suits. That's the main. There's no return because we are going to be using an array, which is by default by reference. So whatever changes I make to the array in this sub are going to be kind of carried through the whole class, not through the whole program. So let me code it first, and then we will go through the comments. They will make more sense, I think. Again, like I said before, I already have these coded, so that's why it's easier for me now just to type it. For I as integer, we're going to populate the deck, and the first we're gonna populate it with the 13 cards. Like each suit has 13 cards, and there are and in it equals 0, and within it we need to also loop through the suits. That's 4 suits: hearts, diamonds, clubs, and spades. So we will do an inner loop that will loop through 0 to 3, which is going to give us obviously the 4 suits. Now I need to figure out obviously when one suit starts and the other one starts. I mean, one stops and the other one starts. So I need to create an index for the card, for the current card that we are creating. So it's gonna be index as integer, and the index for that card equals I, which is the face value of the card. That it's going to be it's gonna be 2, 3, 4, 5, and so forth. We are going to multiply it by 4 because we have 4 suits, and then we will add plus j. Now in the comments, we are looping through 0, so card value needs to be plus 2. We don't want a card value of 0 or 1, so the minimum card value is 2, unless it's an ace, which is obviously handled separately. Now the index of each new card is I times 4 plus j, where I is index of the card value, which is going to be the 2, 3, 4, 5, and so forth, and j is the index of the suit. And 4 is used because in the inner loop, because we are looping through the suit and there are 4 suits. Alright, so let me code the rest of it so you can see where I'm going with it. So at deck we are populating the array, not the stack yet, of the index equals new cards. We are creating a new structure. Remember, we are creating this. We are going to populate the card value, the string value, and the suit. So our deck index card value equals I plus 2, because again we starting from 0, so we don't want 0. We want to start from basically 2, 3, 4, 5, all the way to 10. Now deck index card value string equals, and I'm going to create a method called get card value, because we need to get the card value for jack, queen, and king, and ace separately. All the others will have a regular card value, simply a numeric value, like I said, 2, 3, 4, 5, all the way to 10. But the jack, queen, and king, they will have all numeric value of 10, but we want to preserve the string value for the output. So I'm gonna call card value, and I'm gonna pass a plus 2, I plus 2 to it. So right now I don't have the method, that's why it's still underlined. So what this is going to do, it's going to create, remember we have an array of cards. So each element, each index of the array needs to be populated with a new card and a card value, and in this case also the string value. So I'll come down over here and I'll do the get value. So it's gonna be a private, and it's gonna be function get card value, and it expects the card value as integer, and it returns a string. Oh, there you go. So here we have the card string value will be Jack, Queen, King, or Ace, and we are passing to it the current index plus 2 again, because we start from 0 and the minimum value is 2. So let me place some comments in there right above this this function. So it assigns string value of Jack, Queen, King, and Ace based on the initial face value of each card. And default will simply return the string value of the integer for the cards 2 through 10. Now the parameter that is being passed into this function is a face value of the card 2 through 14. Remember, we have cards, there are 13 cards of each suit. So at the beginning, each of them has their own value, their numeric value. But again, Jack, Queen, and King and Ace have a Jack, Queen, and King have value of 10. Not even though Jack technically at the beginning has 11, Queen would have 12, King 13, and Ace would have 14. That's how by default, but we have to reassign those values to match the the rules of the game. So the function itself is just a simple select case, and we expect the card value. Based on that, we will return the string value. So our case 11, if this is 11, if the card value is 11, we will return string value of Jack. And if the case is case is 12, then we will return Queen. If case is 13, we will return King. And if case is 14, we will return Ace. And case else, which is the default, in other words, if it's 2 through 10, then we will simply return the card value, which is the integer value converted to string. And that's that. That's the whole function of how we get the string value of the card. Alright, so let's come back over to our create deck. So after we call that, after we call the get card value, we can move on with creating our deck. It's still within the loop. So now that we have Jack, Queen, and King, we can assign them value of 10, like I said before, and assign value of 1 to Ace. That's just by default. Like I said, Ace can be also 11, but by default we'll assign a value of 1. So if deck index card value is greater than 10 and deck index the card value is less than card value is less than 14. In other words, it's between 10 and 14. I mean 11, 12, 13. So then the card value will be 10. So our deck index card value equals 10. Else if the index is the card value is 14, which would be the ace, then we will assign the value of 1. After the bracket, card value equals 1. Actually, no. You know what? The default value, let's make it 11 instead of 1. Yeah, let's assign the default value of 11. And then we will determine, because remember, if I get a default value of 1, at the beginning I get 2 cards. So if I get a 10 and ace, that would be 21 and I would win. But if I assign value of 1 only, by default it would only be 11 before I would even check whether it needs to be 1. So yeah, let's make it 11 and then we will be checking if it's too high. If it would make it over 21, if that's the case, we will reassign the value of 1 to ace. But by default, let's make it 11. So, and after this, still within the inner loop, we will now have the card finally. So our card for this element for the suit will simply equals to j, because j is the index of the suit. We have 4 suits, so over here this is 0, 1, 2 and 3. So if j equals 0, then the suit equals hearts. If j equals 1, then it's diamonds, and so forth. So now our deck is populated with 52 cards, but they're in order. So what we have to do next is to shuffle the deck. So I'm going to create a method and I'm going to call it after both the loops are finished. We will shuffle deck. Now I don't have it yet, so let's create the method or the sub, and I'll just scroll down. Private sub shuffle deck. So okay, it took it. So and it's still gonna be randomized. So we will do dim rand as new random, and we will do dim card index as integer. Now we will simply loop. I have it set up for 10,000 iterations. It's really up to you how many times you wanna iterate through the deck. It just it's a shuffle simulation. So for I as integer equals 0 to 10,000, and within it for j as integer equals 0 to 51, because we have 52 cards. So our card index, we will simply switch the cards. So we will randomly select the card that next from the deck, and we will swap it. So but we will only swap it if j does not equal the actual card index. We don't want to swap you cannot swap the card with itself. So if j is not equal to card index, then we will call a function, or a sub called swap cards, and we will pass the indexes, the J and the card index. So again, I'll paste some comments above, but this is fairly self-explanatory. It simply goes shuffles it 10,000 times, and within it we will have the actual cards, the deck of cards, and we will randomly select one card from it, and if it's the card not that is already being selected by within the loop by J, then we will swap the cards. We will swap the J with the card index card. So over here we will do a private sub swap cards, and it expects the J as integer and card index as integer. So these are the two cards that we are going to swap. Again, it doesn't return anything because we are still dealing with the same array. So let me paste the comments. So basically we are going to perform card swap by using temporary card holder. Index of the card being swapped is the J. Card index is the index of the randomly selected card that is swapped with the original card of J. And we are working with a deck which is accessible via reference, so no return value is needed, like I said before. So to swap the cards, we will create a temporary card as cards, as the structure cards, and our temporary card will equal, we will simply place the J card with the index J in it. So now a deck of the index of J can equal to the card that we are swapping with, so which is the card index element. And now we can do the card index will equal to the temporary card, and that's the whole swap. Deck index, sorry, it's supposed to be card index. That's the whole swap method. Alright, so now after we shuffle it over here, after we shuffle the deck and swap the cards, like I said before, we could use it as is already, but I wanted to use the stack, so I'm going to create a stack. I'm going to call shuffled. Now this is shuffled deck, so this is one will be shuffled stack method or a sub. Alright, so our shuffled stack will simply return the stack of cards that is being shuffled. So private sub get shuffled stack, and let me pass the comments in there because there's a little thing that we have to pay attention to. So we move the cards from the array, from the shuffle deck into a stack. Now there's no return again because this is all by reference, because it's all basically pointers. It's an array or a stack, so we don't need a return value because they are being modified within the sub. Now again, this was not needed. We could just keep using the array of deck of cards. I wanted to practice data structures, and stack was perfect for this. Now we use the deck of cards. Then there's going to be, let me code it, and that will again make the comment a little more. It will make a little more sense. As in equals 0 to 51, and our shuffled deck, which is the stack, we will push a card from the array deck, and the card we are pushing is 51. The element is from 51 minus I. And here's the why. We use 51 minus I, and this is done so we can move the bottom card, which is the index 51, to the bottom of the stack. In other words, we want to use it first. We want to go from we want the one card that is on the top of the array. We want to preserve the order, basically. And this is the way to do it. We start from the bottom because this is a stack. So, you know, this is whatever we put in there first will be pushed towards the bottom. Like we will put cards on top of it. So if we just use the first card from the array deck, that's the actual card that should be on the top. But if you use that first and we'll push it to the bottom, it's gonna be the last card in the stack. So we'll push in the cards into the stack from the bottom. It's basically like if you just move the whole array all at once into the stack, you would preserve the order. So that's why we're starting from the end to create a stack and have the card that is on the top in the array to be on the top in the stack as well. Alright, so these are our classes. In the next video I'm going to code the logic for the game. So hopefully I'll see you in the next video. Take care. Bye bye.